Okay friends, let us continue with chapter 12 mathematics, class 12 mathematics, chapter 3, inverse of a matrix by elementary row operations. So in the previous video we have already seen invertible matrices. A square matrix A of order n is said to be invertible if there exists a square matrix B of order n such that A into B or B into A responds to I. Now in that case, of course, B is also called the inverse of the matrix A. Then of course we denote and we write A inverse as B. Now how do we proceed to solve this? But before that, there is one theorem, that is every invertible square matrix has a unique inverse, uniqueness of inverse theorem. Now how do we find out the inverse of a matrix? By elementary row operations. Now how do we proceed to find out the inverse of a matrix? We have already seen how to find out the inverse of a matrix by determinant method. Now by elementary row operation method. Now let's see, this is the procedure. Let's study the procedure today. Let A be a square matrix of order n. Then we can write A also as A I into A, because I represents the identity matrix. So now what happens is, now let a sequence of elementary, I'll just write in short, row operations reduce the matrix A on the left hand side of equation 1 to identity matrix, and I on right hand side of 1 to another matrix B. So in that case we will be left with, after the operations, I equal to B into A. That is, when you have, if this is a procedure, so let A be a square matrix of order n, then we write A equal to I into A. That can be written. Now let a sequence of elementary row operations reduce the matrix A on the left hand side to I, and simultaneously the same operation that you apply will be applied to I also, which will reduce it to another matrix B. Then you will be left with I, this will change to I, this will change to B into A. So now the proof, this implies I into, will be pre-multiplying by A inverse on both sides, so post multiplying, that is B into A inverse. So that will be I into A inverse, of course will be A inverse, that is B into A inverse. Now A inverse equal to A into A inverse will be I, so which implies A inverse is B. That is, the matrix on the right hand side, which you have converted from an identity matrix to the matrix B, another matrix B, will nothing be but the inverse of the matrix A. That means among A equal to I into A ba shuru koribo na, alright, this step kuri na jai na A to ge man identity matrix by elementary row transfer operations only. Okay, I change koribo to the same operation yati ki cholai IDB cholao, to itu another matrix A di change, another matrix B di change ho jabo, itu da man eku operation change no koribo na tate. So in that case, after the elementary operations, you will be left with this operation. So amount theorem is up, A into B equal to B into A. If it all gives us I, then B is nothing but our inverse A. Okay, so like method 2, I'll just give you the algorithm also. Method 2, like step 1 amount ki kurubo, we will write A equal to I into A. Okay, or step 2 to amount by using Muini shortly likhibo to gantu tinian likhibi. Okay, by using elementary koi, I'll also write at the best arrow to gan arrow likhi dishi bole hoise by using elementary row operations on A, transform it to a unit matrix. Step 3, in the same order we apply elementary operations on I to convert it into a matrix B. Our last step 2, you will be left with then A inverse will be equal to B. Okay, ekta example try kuri sabona. Example 1, that is by elementary row operations. My question to nilikhibo, convert this into an invertible, find out its inverse. So manki likhibo A equal to I into A. So A will be 1 minus 2 2 minus 6 equal to I 0 0 1 into A. A to itini ai chhari dibo de. Itu biji de tu la khushi sa pra transformation to cholabe itu gi identity matrix convert koribole try koribo, and same operation jeti cholabo to it will be change hoi thakibo na, to until you get an identity matrix. So it's actually like you can mui la idea to like generally to it is already one ase na, so at least one row to ki pura convert koribole try koribi into one identity column na, identity column that is like, so suppose it is already one ase, so no problem here, to it ki 0 try convert koribole try koribo na. So what operation that I will apply here is muyate r2 to ki dola change koribo paribo na, r2 minus 2 times of r1 itu to paribo na, r2 equal to 2 times of r1, that we can change to na. So in that case we will do r2 equal to r2 minus r1. So r1 to change no koribo, amount in ai likhibo, r2 to change koribo. So r2 to change korisi bole to edi ki hobo, r2 the corresponding elements na, 2 minus 2 times of 1, 2 times of r1 na, equal to 2 minus 2, that will be 0. Or yeti 2 minus not 2 r2 to is minus 6 na, minus 6 minus 2 times of r1 to minus 2, so minus 6 plus 4 to yati ki hoi jabo minus 2. It is same operation to yati bi cholabo na, so 0 minus r2 minus 2 times of r1, 0 minus 2 minus 2, yati 1 minus 2 times of 0, 1 minus 0, that will be 1. Now next step to sabi to ekta column to hoi jaise to na, to itia amount itu column to gi identity matrix element itu 0 1, that means itu 0 koribole try koribo, itu 1 koribole change koribole try koribo na. So itia key operation cholaise bole paribo. So let's see what can we do. Itu 0 or itu 1. Maybe we can do one thing. Apne la khushi ase ali itu to 1 change koribo paribo, because divided by minus 2 korise gole itu ge 1 olai jabo to na. So let's try 1 minus 2 1 0 r2, each element I will divide by minus 2. All these operations you can do. Okay, itu by kwa kiman exercise solve koribo, kiman question solve koribo, tu sapra different varieties to aibo na, different steps, different ways na. So 0 by minus 2 itu to 0 hobo, minus 2 this one, minus 2 by minus 2 yeti 1 olai, that means see to column it to be almost ready na, yeti minus 2 by minus 2 1 1 by minus 2 to minus 1 by 2. Next step to it to khali ekta step bi bachi jaise, that is khali itu 0 change koribo laibo. So itu kuri na see almost we ba kwa nisina itu matrix to gi amagan 1 0 0 1 change koribole try koribo, to ita almost olai jaise na, khali itu element tu bachi na je. So yati ita key operation khali le bal hobo. So what operation can we apply? That means like r1, if we just write r1 plus 2 times of r2, so r2 to almost there, I will not change. R1 to 2 times to yadi to change no 1 2 minus 2 plus 2 ones are 2, minus 2 plus 2 0 allowed na. Okay, so let's start with this element. So 1 plus 2 times of R2 corresponding element 0, so 1 plus 0, sorry, 1 na. Minus 2 plus 2 times of 1, minus 2 plus 2 0. So see, we'll see that this is to complete, it will be complete 1 plus 2 times of 1, 1 plus 2 3, area is 0 plus 2 times of minus 1 by 2, 0 minus 1 to minus 1. So this is in the form of I equal to another matrix into A, that is, which implies B will be our inverse of the given matrix, 3 minus 1, 1 minus 1 by 2. Okay, so this is the operation that we generally apply. Of course, you can also check like verification, because verification koisa pra B to A inverse, and in that case A into A inverse should give me an identity matrix if it is really true. So A to matrix ki daise amount 1 minus 2 2 minus 6 into A inverse we got 3 minus 1 1 minus 1 by 2. So let's multiply first row first column. 1 3s are 3 plus minus 2 na. Next to, sorry, first row first column, I'm also getting confused now, sorry. First row first column, so one into 3 2, this is done. Next first row second column, 1 into minus 1 minus 1, 2 into minus 2 into minus 1 by 2, minus minus plus 1. Again second row first column, 2 3s are 6 minus 6, 2 1s are minus 2, minus 6 into minus 1 by 2, 2 3 plus 3. So what do we have? 1 0 0 1. So you will see that we get the identity matrix. So this verifies that our inverse is really correct. So this is the procedure that you'll be applying. So please make sure that you practice enough. We'll try to solve 1 or 2 questions in the upcoming videos. So please stay at home, stay safe. From the team of Teach Nagaland, please do put a like on our videos, subscribe to our channel, and share it with maximum of your friends. Thank you so much.